This will be a rather brief video. I'm just going to really show the circuit right now. So basically we have two splitters that makes the 4-digit input into single inputs. And then the tunnel connects all of these are the X's, these are all the Y's. And then I got a Y times X column. So it's Y0 times with every single digit of X, and then by times, I mean multiplication, and that's done with AND gates. Because 1 times 0 is 0, 0 times 0 is 0, 0 times 1 is 0, 1 times 1 is 1, and that fits the truth table of an AND gate, right? This is the row for Y1, and then a row of adders, another row for Y2 with all of these X digits, another row of Y3 with all of these digits, and another adder, and all of the results. And then finally we have the output. That's also using a splitter to combine it all together. So why do we have this? Well, I did write a graph that explains the reasoning. So basically it is same as multiplication of decimal numbers that we learned in elementary school. Basically you do the two numbers, and then you use this 0, the last digit y0, to times with each one of these, so it'll be all zeros. And then 1 times all of these, 0, 1, 0, 1. 1 times all of these, 0, 1, 0, 1. And then 0 times all of these, 0, 0, 0, 0. So these are all done with the AND gates I mentioned before. So this fits with the Y0 and all of the other digits row. The second one, this one, fits with this stuff, and so on and so forth, right? And then we have to add all of these 4 rows together, which is done by adders. And then the results are added with the other adder, and the results are added with the other adder. And all of these final results, including all of these are put down, and that's the final result, which is correct because that's how you calculate multiplication. So these are the 3 rows of adders that's required to add the 4 rows together. So it is actually quite simple in this way, just because it's same as decimal places multiplication. But you just have to realize how to implement this in a binary way. So basically 2 digits, and then combining and then using the AND gates as the multiplication. I have 2 cases tested out. On my lab report, 5 times 6 did return to be 30, and then 0 times 0 does return to be 0, and then 15 times 15 does return to be 255. I've done some other further testing, but then they all seems fine, so I did connect them all in the manner of the schematics, so I'm pretty sure I did this well, and then I think that's it. I learned how to multiply using all of these electrical components.